So in this video, we're going to look at solving basic sine equations that have the form sine theta equals a, but we're going to focus on the case where a doesn't correspond to a special angle. The technique for finding the solutions will be the same as if we were working with a special angle. So it says find all solutions to the following trigonometric equation. Sine theta equals negative 2/3, and we want to recognize that negative 2/3 does not correspond to any of the special angles that we know on the unit circle. And we want to find the solutions on the interval from 0 to 2 pi. So the way that I like to do this is just find all solutions first, because I think it's a good habit to get into, and then find solutions on the interval of interest. Because I'm given the interval from 0 to 2 pi, this implies to me that I need to be working in radians. So I'm not going to worry about degree world right now. I'm going to worry about radian world. And to solve sine theta equals negative 2/3, we're going to need to take this and apply the inverse sine function to both sides. And we know that the inverse sine function has angle outputs that live between negative pi over 2 and pi over 2. So the sine inverse function is defined on the interval only from negative pi over 2 to pi over 2. So here I've graphed the function sine theta, and I've graphed the line y equals negative 2/3, and we can see that we get solutions every time the line y equals negative 2/3 intersects the sine graph. However, for the sine inverse function, we are going to get a solution theta sub 1, that is on the interval from negative 90 degrees to 90 degrees, or negative pi over 2 radians to pi over 2 radians, which is the only place where the sine inverse function is defined. So the sine inverse function is going to give us the principal solution, which is the solution on the interval over which the sine inverse is defined. So we're going to get this ordered pair theta 1, input theta 1, output negative 2/3. The sine inverse function gives us this angle on this interval. So to get that angle, I go sine of theta sub 1 equals negative 2/3. I take the sine inverse of both sides, and I get theta sub 1 equals the sine inverse of negative 2/3. And this is the principal solution. This is the principal solution. But we know that every angle coterminal with this angle, so this is to the right of the trough, there's another intersection to the right of the trough, another intersection to the right of the trough, these are all coterminal with this solution. So we know that any angle theta is a solution if it is coterminal with theta sub 1. So we describe our coterminal angles. Hey, any angle theta that's coterminal with theta sub 1 will be equal to theta sub 1 plus 2 pi, a full rotation around the circle, times k, the integer generates the rotations around the circle, where k has to be an integer value, 0 plus or minus 1, plus or minus 2, etc. But theta sub 1 is the sine inverse of negative 2/3. So sine inverse of negative 2/3 plus 2 pi k gives us all of the solutions that are coterminal with the principal solution theta sub 1. So everything here is a solution of the original equation. But we know that from the previous video there is a second solution that is the supplement of the first solution. In other words, we know there's an angle theta sub 2, and here he is right here in the picture, that also generates an output of negative 2/3, and he's the supplement of theta sub 1. Notice he's to the left of the trough, not to the right, and he's going to correspond to every intersection that is to the left of the trough. So we know from the previous video that theta sub 1 plus theta sub 2 equals pi radians, or 180 degrees, which means if we subtract theta sub 1 from both sides, we get theta sub 2 equals pi minus theta sub 1. So here's this guy right here. But any angle that's coterminal with theta sub 2 is also going to be a solution to this equation. So I'm going to get another set of solutions. Theta equals any angle coterminal, so plus 2 pi k to get to coterminal angles, any angle coterminal with theta sub 2 is also a solution, and of course we know that k needs to be an integer. But what does theta sub 2 look like? Well, theta sub 2 is just the difference between pi and theta sub 1. So this just equals pi minus theta sub 1 plus 2 pi k. And we know that pi minus theta sub 1 is just the sine inverse theta sub 1. It's just the sine inverse of negative 2/3. And then we get our plus 2 pi k. So that was probably a clunky process for generating those. So I usually shortcut this. So if I discard this mess and just start from scratch, trying to do a little bit more direct approach, whereas the previous was trying to explain it a little bit more conceptually. Let's just refire things up. Let's solve this. Okay, so we get sine theta, I'm not going to worry about the theta sub 1s, equals negative 2/3. So theta is going to equal negative 2/3 plus, it's going to equal, I need to take the sine inverse of both sides, the sine inverse of negative 2/3. But I need everything coterminal with this, so I'm going to go plus 2 pi k. And the moment I do this, I know that I also get a set of supplements as solutions as well. So I also get angles that look like this. Theta equals, I need the supplement of this angle, so I have to go pi minus this angle here to get its supplement. So I'm going to go pi minus the sine inverse of negative 2/3 to get supplements. This gives me supplements to this angle right here, plus 2 pi k. And there I've described all of the solutions. This describes all solutions right here. These two statements. This guy and this guy. There's all solutions. But we're supposed to find the solutions on the interval from 0 to 2 pi. And what I want to recognize is that this right here, this sine inverse of negative 2/3, corresponds to this right here. So but if we want the solutions on the interval from 0 to 2 pi, this guy falls outside of that interval from 0 to 2 pi. So what I need to do is get the next coterminal angle over, which is located right here. We need to find this intersection. So to get him, I'm going to just add 2 pi. I'm going to let k equal 1. When k equals 1, I get theta equals the sine inverse of negative 2/3 plus 2 pi. That's going to give me this angle right here. The angle that was the supplement for this one is this guy right here, and he's already on the interval from 0 to 2 pi. So for the other solution, I'm just going to let k equal 0. So if I let k equal 0, I just get another solution on the interval from 0 to 2 pi. It's going to be pi minus the sine inverse of negative 2/3. And usually textbooks will give you instructions not to round intermediate steps, so I haven't rounded anything yet. I said here's one solution on the interval from 0 to 2 pi, here's another one, and then at this point you step out to your calculator if you need to estimate these. These are the exact answers. These are exact. If you need to approximate these to some specified place value, then you would step over to your calculator. So we'll go ahead and keep that. You would just step over to your calculator, and the first thing that you would do is click into mode to make sure you're in the correct mode. Here I'm in degree mode, so I would switch over to radian mode because I'm working in radians, and then I would step back out to my main screen, and the first equation was to take the sine inverse, so second sine inverse of, and it was negative 2/3, and we were adding 2 pi to it, so plus 2 second up arrow to get at the pi, plus 2 pi, and we'd hit enter. So to the nearest tenth, we'd get 5.6 radians. And for the other solution, the statement was pi minus the sine inverse of negative 2/3. So we would do that. We would say to get the other solution, we go second pi minus second sine to get the sine inverse function. And it was negative 2 divided by 3, or negative 2/3. And we'd hit enter. And this gives us about 3.9 radians. You would round both of these values based on what you were specified to do in a homework assignment, or if you were asked for the exact solution. If you were asked for exact solutions, you would leave them just like this. Here's one angle, here's the other angle.